Alright, so my final project is geometric series and applications. A geometric series is the sum of the numbers in a geometric sequence, and often these two are connected, but a geometric sequence is different than a series because, as you can see, a sequence has the commas in between the numbers, whereas a series has addition. Both the series and sequence will have a common ratio. As you can tell, it always is moving and increasing or decreasing. And so that common ratio is found by using the second term divided by the first term. So if you want to find the ratio of the series we're looking for, you use A2, which would be 6 in this case, divided by A3, or by 3 would be A1, and you would get 2. So the ratio for this example would be 2. And in doing so, you then get finite series and infinite series. And finite series are, as you can see here, a set that has a specific number, and this has 4 numbers in it, whereas infinite has their numbers plus ... which means it infinitely grows or decays. So for finite, to find the nth term for the formula, so let's say this has 4 numbers and you want to find the 5th term, even though the 5th term isn't on there. If there was a 5th term, you could use this formula as a to the n equals a1 times the ratio to the n minus 1 power. So using this formula in the example above, since we have 1, 2, 3, 4 terms, one from the 5th term, we have a5 would equal 3 times 2, because our ratio is 2, to the power of 5 minus 1, since our nth term is 5. And doing that, you would get the sum of not the sum, but what the 5th term would be in the sequence to be 48. Speaking on that, then to find the full sum of the finite series, you would then use the formula Sn equals a1 times 1 minus r to the nth power divided all over 1 minus r. So using the same example of 3 plus 6 plus 12 plus 4 plus 48, it has 5 terms in it, so n would equal 5. So you're looking for S of 5 would equal the first term, which is 3, and we got a ratio from doing the second divided by the first term, which would be 2. So 3, 1 minus 2 to the 5th power divided by 1 minus 2. And so the sum of this series would be 93. And then for our last application of geometric series, you would do, this is where R comes into play, where the ratio comes into play, because if the absolute value of the ratio, or R, is greater than 1, the sum cannot be solved, as in it just diverges and the series would just get bigger and bigger and you can't calculate the sum. And then if the ratio is smaller than 1, then the series converges and you can solve the equation. And if so, you can then use the equation S infinite equals A1 over 1 minus R. So for example, using this series right here of 8 plus 4 plus 2 plus 1 plus 1/2 plus infinite, you could find the R using A2 divided by A1, which would be 4 over 8. So our R is 1/2 and our A1 is 8. So just plug those numbers in to the S infinite. So you have 8 over 1 minus 1/2, so you have 8 over 0.5, and that would be 16. And that is how geometric series and applications work.